Welcome back to this video lecture series on data structure and algorithms. Today our lesson is Introduction to Graph Data Structure. So let's start. So first we'll be knowing about the definition of graph, that is what this data structure actually means. So we can formally define the graph data structure like this. The graph data structure consists of two elements. First is a finite set of vertices, also called as nodes, and the second one is a finite set of ordered pair of form u, v, called as edge. The pair is of form uv indicates that there is an edge from a vertex u to vertex v. The edges may contain weight or value or cost. So one thing to notice is that this very particular term here, ordered pair, it means if an ordered pair is defined as u comma v, then v comma u is not equivalent to u comma v. So let's now know about some terminologies of graph. In this diagram here, this is an example of a very simple graph. These are called the nodes or the vertices of this graph, and the connection between these vertices, these are called the edges of the graph. So main two components of a graph are vertices and edges. So the first terminology that we'll be knowing is vertex. Each node in the graph is represented as a vertex, and in this diagram here 0 1 2 3 4, each of them are a vertex. Edges are nothing but it represent a path or a line between two vertices. Like there's this edge 4 to 1, 3 to 1, 2 to 3, 0 to 4. These are called the edges of the graph. Another term is adjacency. Two nodes or vertices are adjacent if they are connected to each other through an edge. In this example, we can see that 0 and 1, these two vertices are connected via this edge, so they are adjacent nodes. Like this 0 and 4 are adjacent, 3 and 2 are adjacent, 2 and 1 are also adjacent. Lastly comes path. So path represents a sequence of edges between two vertices. So if we say the path from vertex 0 to vertex 3, we can have this 0 to 1, then 4, then 3. So this is a path which consists of the sequence of some edges. 0 to 1 one edge, then 1 to 4 another edge, and lastly 4 to 3 another edge. Now let's move forward and let us know about the representation of graph, that is the ways in which we can represent the graph data structure. So the two most common graph representations we have are adjacency matrix and another is adjacency list. In this diagram here, this is the example of adjacency matrix. So as we can see, it is nothing but it is a two-dimensional array, and the size of this array is square of v, where v is the number of vertices in a graph. This representation is very easy to implement and follow, but it consumes more spaces. What happens is most of the times all of these array indexes are of no use, it can be seen, so the space consumption is an issue here. The next representation is called the adjacency list. What is it? So here an array of linked list is used. Size of the array is same as the number of vertices of the graph. This representation consumes less amount of memory to store graph vertices. The reason is, so suppose we have these 5 vertices 0 to 4. What we do, we take an array of linked list. This is a linked list, another linked list. So at these indexes, a linked list is stored. And in this linked list, what is done is, for this 0 edge, this 0 vertex, all the other vertices which are connected to this 0 vertex are stored here using this linked list representation. So from this representation, what we can interpret is, with this vertex 0, the vertices which are adjacent are 1 and 4. With vertex 1, the adjacent vertices are 0, 4, 2, 3. So it's just like this. Next is, we will be knowing about the basic operation that we can perform on graph. So very basic and primary operations are, first one is add a vertex, which adds a vertex to the graph. Next one is adding an edge between two vertices of a graph. And lastly, displaying the vertex of a graph. Lastly, we come to the important part, that what are the applications of this graph data structure. To be honest, graph is definitely and undoubtedly one of the most important data structures, which has a huge number of applications. For examples, it is used in networks of communication like Facebook, LinkedIn. Graph theoretic methods in various form have proven particularly useful in linguistics. Graph is also used to study molecules in chemistry and physics. So not only in the field of computer science and networks, it ranges in very other fields in which this particular graph data structure or the graph entity can be implemented. Thank you for watching this video and staying with us. See you next time.